Now the first problem that you see is we have two categories of people. People in a room. Now we're given that there are 30 people in the room, so I'm going to write that 30 here to indicate that this box could represent the room and the classifications of the people. One classification is D for dark hair, the other is B for bright eyes. Okay, I don't know exactly what the definition of dark is, I don't know exactly what the definition of bright is, but we assume we have one, okay, that applies to hair and another that applies to eyes. Now we're given some information. One bit of information, of course, is that there are 30 people in the room, and I've already indicated that. The other piece of information, well, one bit of information is that there are 25 that have at least one of the characteristics, okay? And then that there are 12 people who have dark hair but don't have bright eyes. Well, that would be indicated by the region of this circle, of this set diagram, outside of the region where we have the people with bright eyes. So that would be 12 if I've got that number correct. And then we also know that there are 10 people who have both of these characteristics. So we have 10 people here. And now we want to determine answers to various questions. How many people have dark hair? How many people have bright eyes? How many people have bright eyes but not dark hair? How many have dark hair but not bright eyes? How many don't have either of these characteristics? Okay, so what we know is that there are a total of 25 people in these two sets. Okay, now these two sets, in the combination of these two sets, in the union of the sets D and B. And we know that the union of these sets, or the set that contains all the people with dark hair or bright eyes, has 12 people with dark hair, 10 with dark hair but not bright eyes, 10 with bright eyes, and then some undetermined number that have bright eyes but not dark hair. And I'm not sure I said that right. The 10 is both characteristics, dark hair and bright eyes. So again, we have people with dark hair whose eyes aren't bright, 10 people with dark hair whose eyes are bright, and some undetermined number whose eyes are bright but whose hair is not dark. Now, what information do we have that would allow us to determine the number of people here? Okay, well, there are 25 people combined in these sets. 12 are accounted for here, 10 are accounted for here. That's 22 of the people. The other 3 have to be here. So we get that by taking 25 minus the 12 minus the 10, and that equals 3. So there are 3 people in this part of the set. Also, there are people that don't have dark hair or bright eyes, neither dark hair nor bright eyes. And those people will be outside both of the sets. Well, there are 25 people within these two sets and 30 people total, which means that there are 30 minus 25 equals 5 in the region outside the two sets. And we could say then that the number in the set, which consists of the bright-eyed people who are not dark-haired, and that set would be the set B minus D. B minus D meaning the set of everything that's all elements in B except those which are in D. So we take away the ones that are in D. That number is equal to what? It's equal to the 25, which is the number in B union D, the union of the two sets, minus this number here, which is a number in the intersection of the two sets, minus the number here. which is the number in D minus B. And this, of course, is just a rearrangement of what we could say is kind of a big rule for two sets, that the number in B union D, the number in the union of these two sets, is the number in B minus D, which is the number here, the 3 in this case, plus the number in B intersection D, which would be our 10, plus the number in D minus B, the part of D that doesn't include any of B. And there's another way to write the same idea, and you can think about this, but the number in B union D is the number in B plus the number in D. But we have how many? We have 13 elements in B, and we have 22 elements here. 13 and 22 is too many, because there are only 25. 13 and 22 is 35. Well, how do we reconcile that? If we add the number in D to the number in B, we've included this 10 twice, because it's included among the 22 that are in D and the 13 that are in B. So in order to reconcile that, we subtract the number in B intersection D. Okay, so you can think about these relationships. None of them are mysterious. It's not like formulas that you have to remember. It's a picture that makes sense. Now, we could say, and I didn't write it down, but the number in D is the number in D minus B plus the number in D intersection B, because, and of course that equals 12 plus 10 equals 22, simply because the set D equals the set D minus B union the set D intersection B. Maybe I shouldn't have said that. And these two sets are disjoint. Okay, so you can think about that. Okay, but this whole idea of representing the numbers of objects, number of elements in different parts of two sets and in different parts of the universal set is very powerful. You can answer a lot of questions, sort out a lot of things using this sort of diagram. There are 4 regions, 1, 2, 3, 4. If you know enough information, you can figure out the rest. By enough information, I mean the number of, you want to figure out the total number of elements that are in each of the 4 parts of this set. Then you can answer just about any question.